Now see application of Biot-Savart law. First one is here magnetic field at a point on the axis of a circular coil carrying current. So now see here we have to calculate magnetic field at a point on the axis of the given circular coil. Suppose we have taken a circular coil like this, where the current is flowing in anti-clockwise direction, and now this is the center of this, and now we have to calculate magnetic field at any point here P. This we can take as x axis, here we can take this is as a y axis, and now this is we can take as z axis. This point is O. Suppose the radius of the loop is r, you are going to get magnetic field at a point on the axis at a distance x from the center. First we assume here a small current element, here, whose length is dl, and that is going to this side here, and the distance from this dl to this point is, suppose this is r, which is equal to actually r square plus x square. Now similarly we can take here small element over here, that is a dl here, and at this point magnetic field is here, this is also equal to r. So see here the direction of magnetic field at this point, which is perpendicular to both the vector r and dl, that is this side, that we can take vector db, and here we can take here that is db dash. Now this we can draw here as x y axis here, this angle is phi, this angle is phi, so this is also phi and this is also here phi. This has got the two component db cos phi to here and db sin phi to this side. Similarly here db dash cos phi to this side here and db dash sin phi to this side. So since this figure is symmetrical, so this component along the y axis, that is the db cos phi and db dash cos phi, will get cancelled, and only the net magnetic field will be obtained along the x axis, that is db sin phi plus db dash sin phi. So now here we will discuss it, but here the vector dl and r perpendicular to each other, that because this line will be the tangent to the this part of the circle dl here, so that angle will be here the 90 degree. So now we have to calculate magnetic field by using the integration process, because we know the magnetic field due to small element, so we can calculate due to the whole circle. So how do we calculate it here? Let us see. First we will write the value of db and db dash. So we can write magnitude of db is equal to magnitude of db dash is equal to mu naught I dl sin theta upon 4 pi r square, that is using Biot-Savart law, where the theta is angle between dl and r, and this is equal to here 90 degree. So if the theta is equal to 90 degree here, then we can put it here, this thing is here, and we can write this equation again here, and we will be getting mu naught I dl upon 4 pi r square. So this is the magnetic field due to small element at this point, and this magnetic field is equal because of this dl and this dl, that means db and db dash will be equal. So see here db cos phi and db dash cos phi will get cancelled each other, will get cancelled. So now the net magnetic field will be at the point P is equal to, that is db sin phi, and integration of that is 0 to 2 pi r. We can put the value of db, so we will be getting 2 pi r, that is mu naught I dl upon 4 pi r square, and now sin phi from the triangle can be written here, that is equal to r upon r here. You can look at the diagram. and this one now we can integrate it. So, mu naught I r upon 4 pi r cube integration of that is 0 to 2 pi r dl. So, we can calculate, and this b we will be getting here, that is b is equal to mu naught I r upon 4 pi r cube into 2 pi r. This pi and this 2 will get cancelled. As a result, here now we will be getting b is equal to mu naught I r square upon twice of r cube. Put the value of r was there under root of r square plus x square. So, we can write b is equal to mu naught I r square upon twice of r square plus x square raised to power 3 by 2. Now, see here, if the coil has got n number of turns, then we can multiply this expression by n, and we can write here this expression. If there are the n number of turns, so we can write b is equal to mu naught n I r square divided by twice of r square plus x square raised to power 3 by 2. This is for the n number of turns in the coil. Now, if you want to write in vector form, here you can write I cap, because in the diagram net magnetic field is going along the x axis. If you are taking x is equal to 0, that means at the center of coil, So, if x equal to 0, then we can write b is equal to mu naught n I r square divided by twice of, here we can write r cube, and this will get cancelled, and we will be getting mu naught n I divided by twice of r. So, this is the magnetic field at the center of the coil. So, first we have calculated magnetic field at a point on the axis of the coil carrying current I, and then we have converted it into the center. So, this is the first application of Biot-Savart law.